In this problem, we're going to find this limit of a function f as x approaches 2. But we're not given what f is. Instead, we're given one other piece of information of it, and that's that the limit as x approaches 2 of 4 minus f over 2 minus x is actually negative 3. So first what we're going to do is try to figure out what the limit of the numerator would be as x approaches 2. Because we can see the limit of the denominator as x approaches 2 would be 0. But what would happen to the limit of the numerator? So notice that I can rewrite the numerator as the original fraction that I have here times its denominator. But using limit laws, we can actually evaluate this limit on the right-hand side. So take a minute, put this on pause, notice what the limit is on the right-hand side, and then tell me what that means about the limit of f as x approaches 2. Okay, so using limit laws, I know that if I want to take the limit of a product of two functions, if the limit of the functions themselves exist, so the limit of this inside function as x approaches 2, well, that's what we were given. We know that exists. And we know the limit of this function, 2 minus x, as x approaches 2. That one exists. That's also just 0. So if both of those limits exist, then the limit of the product of the functions is just the product of the limits. So in this case, just 0. But then if we know that this limit equals 0, again by using limit laws, that means that we know that the limit as x approaches 2 of 4, so now I'm just basically using limit laws to think of both of these limits separately. We know that the difference between these two limits have to be 0, which means that this limit has to equal this limit. And we know this limit's just 4. So this problem was just helping us apply the concepts behind limit laws to this particular example, and in this case we were able to find this exact limit.